Welcome friends in Science Lecture 2, Lesson 13, Magnetic Effects of Electric Current. Now in this particular chapter today we are going to learn the topic of force on a current carrying conductor but in a magnetic field. Now as we have learned before that the magnetic field is created and by the conductor when the current is being passed, it creates a kind of a force. So here as we read little bit here that have learned that an electric current flowing through a conductor produces the magnetic field that we have learned before, and the field so produced exert a force on magnet placed in the vicinity of a conductor. As shown in the figure here, when the magnetic, this is north pole and this is south pole, when you see here the lines of forces passes, is a shoe magnet, and from the north pole towards the south pole the lines of forces are passing, and this is a conducting rod by which the electric current is passing from here and coming towards here, right? You may see here the current is passing from here and going towards this way. So the current is passing through the rod and you may see the force exerted in this particular direction. Now how we suggest this force was given by an ampere. Suggests that the magnet must also exert an equal and opposite force on a current carrying conductor. That means this magnet creates a force on this particular conductor. The force due to magnetic field acting on a current carrying conductor can be demonstrated through the following activities. So this is particular an activity by which this has been created. Now if I explain it by a right hand rule, this is a right hand here, particular right hand, and you may see these lines of force. This is a current passing from this particular and coming to us. So these are the lines of forces. You may see this is a current passing from this particular direction, and this is a thumb's rule, right? And which you see this particular right hand thumb. So you may see here the magnetic, due to this particular current passing through in this particular direction, the magnetic force is created in this particular direction. So you may see here this is a kind of force which is getting direction this way. Fine. So this is a right hand's rule by which you may see this particular direction which is happening here. So this is one way of learning which direction the force is being exerted. The displacement of the rod in the above activity suggested that the force is exerted on a current. Now this can be opposite if I reverse the current. If I reverse the current, the direction of the force will be in this particular direction according to my right hand thumb. Activity suggests that the force is exerted on the current carrying aluminum rod. When it is placed in the magnetic field, it also suggests that the direction of the force also reverses. As I told you, if I reverse the direction of the current, before that this was passing in this direction, now this is passing in this direction. So you may see this is a right hand going in this particular outside direction. Here this is getting inside direction because the current is passing in this particular direction here, right? So this is how we define the direction of a force which is exerted by magnetic field and in current. Now change the direction of a field vertically downwards by the interchanging two poles of the magnet. We can change the direction of the current, we can change the direction of the magnetic field, and by which we can reverse the direction of the. So the direction of the current carrying rod gets reversed. This shows that the direction of the force on the conductor depend upon the direction of the current and the direction of the magnetic field. This is important. Direction of the current and direction of the magnetic field. Either of them are reversed, then the direction of the force reverses. So this experiment shows that the displacement of the rod is largest on the magnitude of the force is the highest. So if you increase the current or the magnetic field, either of them also the force increases. So when the direction of the current is the right angles to the direction of the magnetic field, such the conduction can use a simple rule find the direction of a on the conductor. This is known as Fleming's left hand rule. Fleming's left hand rule. This is my left hand, and three directions I am going to keep. One direction is this one direction is this one, and one direction. They are perpendicular with respect to each other. They are perpendicular. This direction, and this direction. Thumb, which is towards yourself, right? So this is three directions that we are showing. So this is a all three are perpendicular with respect to each other. So according to the Fleming's rule, your index finger, this is your middle finger, this is your index finger, and this is your thumb. So they are all perpendicular with respect to each other. So this shows the direction of the current, this shows the direction of the magnetic field, and this direction shows the force. So they are all with respect to perpendicular with respect to each other. Suppose if I keep this in this particular direction, so this particular is the direction of the current which is passing, and this is the direction of the current which is passing. This is the direction, index finger shows the direction of the magnetic field, and this is the force which is showing in this particular direction. So this activity considers the direction of the current that of the magnetic field perpendicular to each other, and found that the force is perpendicular to both of them. So this and this, the force is in this direction. So this is the towards the like a pencil towards you. This is the direction of the current, this is the direction of the field, and this is the direction. That is, you can say x-axis, y-axis and z-axis, they are all perpendicular with respect to each other. Forces are perpendicular to both of them. The three directions can be illustrated through a simple Fleming's left-hand rule. So this particular rule is called as a Fleming's left-hand rule. If you see in this particular experiment also, you may see that now in this particular experiment, this shows the direction of the field from north pole towards the south pole. This is the direction of the field. This is the direction of the current which is going, right? So this is the direction of the current. So you may see this force is in this direction. Now see this again. This is the direction of the magnetic field. This is the direction of the electric current which is moving in this particular direction, that is moving in this particular direction, and this is the force which is exerting. So this is a magnetic field, this is the direction of the current, and this is a force. If I reverse any one of them, if I keep a magnetic field in this direction where the direction of the field is reversed, then the force is going to be in this particular direction. Fine. So I hope so you understood about the Fleming's rule, how it works. Fine. And you may understand about in different devices like solenoid and all, you may define which direction the current is going to be, which direction the magnetic field, and which direction the force is going to act, right? And according to which the motor, generators and many different equipments work accordingly. Due to this current carrying Fleming's rule and the force which is going to be exerted in this particular. Fine. So I hope so you understood how this Fleming's left hand rule works, and right hand thumb rule also works. Thank you for this particular lecture.